right? We'll be looking at um 2022 paper. We have already answered question 1 and this is question 2, so we are putting this because we are learning and we don't want to have a long video, so we'll be having in series just like this. All right, okay, there we go. This question we'll be doing question 2. Okay, for more you can access, the line is there, we do online as well, so that is it. So this is 2022 question 2 test 1, all right, MA 110. So now we are told to actually express the following in the form of, so we are told to explain the following in the form of A over B in its simplest form, where B and A are just integers. So the first thing that you do is you have what, 3 3 1 2 bar, like that, right? So that's bar. So here this bar simply means that there were a lot of 1 2 1 2 1 2 1 2 1 2 1 2. That's a pattern that we had. So now how we solve this, you say let x, all right, let x be equal to what, to the same thing you have here, which is 3 point, all right, 3 point no, those 3.312, like that, bar. So 1 2 is the one which is in the bar. So the first goal is make at least this independent number be on the left side, and that's what we do. Multiply with what number for the point to come there? That's 10. So multiply, say so we say we multiply by 10. You can be writing, say multiply by 10, so have 10, all right, 10x is equal to, when you multiply that one, it will give you 33 times 10, all right, 0.12 bar, like that. So this is what we call your equation 1. Equation 1 should have all the independent number on the left side. Then equation 2 should have at least the same one which was on the bar also come on the left side. That's, then you are done. So now here, this is equation 1. So we'll have equation 2. So you can tell them to say multiply with a certain number for a point to come there. You multiply times what? 100. So when you multiply times 100, that one, so you multiply equation 1, so we say equation 1 by what? By 100, so that the point can come there. So here we have 1000 x is equal to 3 3, then the 1 2 will come there, all right, because you are multiplying by what? By 100. So that would be 1 2. Again, since they were in a bar, they remain in a bar, like that. All right, we have just moved the point of the other bar. So from there, then you do what? You subtract 1 minus 2. You tell them to say 2 minus 1. All right, so these are the equation I'm subtracting. So what I'm going to do is I'll say this is 1000 x is equal to 3312.12 bar, like that. Then equation 1 we had what? 10x, right, is equal to what? We had the 33.12 bar. Then you subtract, so this will give you 990, right? X is equal to, this will give you, when you subtract that one into this one is 0, of course, then that is what? 12, then that will be 9, then 9, that will be now 0, then 10, there 7, all right, then there was 1, so we'll just remain with it, 20, 30, 32, like that. All right, so we have 990 x is equal to no, I'm not even supposed to. Okay, this is 32 7 9, so we divide throughout by 990. all right, so 990, so we have our x is equal to for me, I think I can't go anywhere. I can't simplify there. I can't. This is just huge for me, so I'll leave it as 27999, like that. All right. So you end there. So this is in the form of A over B, and we can see B is not equal to what? To 0. So that's how you do this one. Let's go to the next question. So that was the answer you needed to put. So the question says show that two functions are given are inverse of each other. In grade 8, I mean secondary level, we used to say the function of a certain, if the inverse of a certain function, you, let's say a function is this, right? We could write to say, we make, let's say y, we let y be equal to what, then the function is just like that. So even that one you can use, or there is another one we use here at the second. So let me start with the one you used. So you say you get, let's say f of x, all right, is equal to what, 4x minus 3, all right. Then you can see that we now say y where there is f of x, then you say 4x, all right. I want to make f of x the function, I want to find the inverse. So before I even do that, I'm supposed to write like that. So you say f of x inverse like that. So that is 4x, right, minus 3 like that. So what you do is you write y is equal to what, 4x, all right, that. So you make what, you make y, x the subject of the formula, so that will be 4x, then the 3 will go there, so that will be y plus 3, all right. You divide throughout by what, 4. All right, so you have x is equals to what, y plus 3 over 4. All right, so that is 4. Then from there, what you are going to do is you say therefore, all right, f of x inverse is equal to what, you put x where there is y now, all right. I'm saying that's 3, I'm sorry. So that is 3 now, all right, and that before, you can see this is now the g, what, the g of x. So we have seen that, so I'll use this type of proving. I won't use that one for a certain condition because it will be very long for me to substitute, but it still give me the same thing. So if again, so we are done there. We have seen that f of x is the what, which is what, equal to g of what, x. You see, so I've found the inverse, and also find the inverse of g of x. Okay, so the inverse of g of x, g of x is given as 3 plus 4 like that. So let's find the inverse. We say y is equal to what, x plus 3 over 4 like that. Then we'll say we are going to say we make x as subject formula, so that will be what, 4x, all right, then is equal to x plus 3. So we'll say x is equal to 4x, all right, minus 3. So now we'll say therefore f, that is g now, all right, g inverse of x is equal to what, by the way, I've forgotten something here. Here it was supposed to be, all right, so that's why. But when you finally substitute, that will be what, 4x then minus 3 like that. So we have seen that this is what, which is equal to what, g f of x. So hence inverse of each other. So that is what you can do. So that's what you can do. Let me just do it again the other way around, of which they normally teach here at the university. All right, so this one, you give a condition to say if the function, if functions are inverse of each other, all right. So if functions are inverse of each other, so you give the statement to say if, all right, functions of each other, you write like that, then you say g of x, all right. So let me write like this. So g of x, f of x like that, is equal to x, and also f g of x is also equal to what, x like that. So that's 1, and this is what, 2. So what we are going to do, let me prove this one to say if it to give me x. So g of x like that, all right, it should give me x if they are inverse of each other. So what I'm going to do is I'll say I'll get g of x. See, you can see f is on the middle between g and x, so we are substituting f of x into g of x. So I'll bring g of x. G of x has what, has x plus 3 over, all right, 4, all right. So we'll see if it will give us x. So I'm putting, whenever there's x, I'm putting the function f of x. So I'll bring it, so you can see x there. So I'll say 4x, all right, minus 3, all right, plus 3, then over 4, like that. So we can see this and this goes, right? So that will be what? 4x over 4, which is giving us what? X. So the condition is satisfied. Then again you come to you test this one again. So you say you substitute, so you bring f of x function, of which it is 4x minus 3, like that. All right, so whatever is x, we are putting g of x because g is on the middle. So I'll say I'll put g of x. G of x is 3x plus 3 over 4, all right, minus 3, which is independent, like that. Then you can see this and this can go, so have x plus 3 minus 3, like that. This can go again, so have x, like that. All right, so finally then, all right, you give the condition, you state that this, then hence inverse of each other. So hence inverse of each other. So that's how you write like that. Okay, let's go to so if a and b are the roots of what quadratic equation, so in short we have the certain roots of this quadratic equation. Find the quadratic equation that has the roots of what? A and b squared, alpha squared and beta squared. So what we do is, for this case, we derive a certain formula. So it's about deriving the formula, but before that you need to know that the sum or the product of any equation will be gotten by, of these two guys, gamma and alpha. So the product, the sum, you say, you do this, you say alpha, all right, I'm saying the sum, alpha plus beta, all right, then is equal to what? Is equal to b, all right, over a, all right. So then the product of alpha and beta, it will be c, all right, over a, like that. All right, so we know the equation will be in the form of ax squared plus, all right, x, all right, then is equal to what? Plus c is equal to 0. So the sum is actually that. The product is the product of this one, right? Then just like that. Okay, so now the form of the equation that we are going to replace in will be in the form of what? We'll have x squared minus, all right, signs should be alternating. Here there's plus, here is negative, then open bracket, the sum of these two guys, all right, then now they are squared, all right, them squared like that, then plus, the signs should be alternating, then we said the product of these guys, so they are squared, so that is b squared and the alpha gamma squared, like that, then it's equals to 0. So that's how you replace the equation. So let's find first, before we come into squared. So negative b of this form is what? 6, right? So that is 6 there. The value of b is what? 6. So we'll say negative 6, so that will be just, there's a negative, so negative 6, then a is what? 3, right? So that will give us what? Negative 2. Okay, then here to find the product, we'll say c is what? Negative 15, right? Over a is what? A is 3, so that will give us what? Negative 5. All right, so we are done there. So that's negative 5. Okay, then the other thing that we need to do is to actually we are going to derive now this one, the squared thing, because it's coming in square. So we are going to derive the formula of which we should substitute there, all right, because we don't have this in our identity, we only have these ones. All right, so what we are going to do is we'll say we are going to say alpha, all right, so alpha squared plus beta squared is equal to what? This is just same as alpha, all right, squared, no, let me not write it squared. I'll imagine to say this is alpha plus beta, like that. They are now in the square. All right, that's the interpretation there. All right, so what you do is you now expand. All right, so we are expanding this. All right, so after expanding this, let's expand. So we have alpha times beta, that's what? Alpha squared, right? Alpha times alpha, that's alpha squared. Then plus alpha times beta, that is alpha beta, right? Again, beta times alpha, that's what? Alpha beta. Then beta times beta, that is what? Beta squared, right? All right, so I can group the terms now. I'll group alpha and beta. All right, so I'll say alpha beta plus alpha beta squared. Then these two can be what? Give us what? 2. You add them, they'll give you 2 alpha beta, like that. Okay, so from there, remember this side we have by the way, I'm supposed to do this thing that you're able to see there. All right, this thing that you're able to, okay, so allow me to lab this part. Okay, so this part we equated it like that. So that part, it was from let me do this. Okay, so don't get confused, guys. This part is the one which we squared. All right, so we are saying this is the part we squared. So this part was supposed to be, in fact, it was from this side. So allow me also to lab the, okay, because it came like this. We are actually coming from this side. So we'll say that is the alpha plus beta. All right, that is alpha plus beta. Then that is in the same as squared, like that. Then here we are just expanding them. All right, of which I did at stage 2. All right, so this is the thing. So here is always this is the subject of this formula. All right, so I'll also write it at this point. Okay, so after doing this, you say you group the like terms. You are interested in what you started with, the one which they gave you. All right, so that's how we derive the sum of what? Alpha squared beta squared. So you take this to the, all right, so that will be alpha plus beta, all right, squared. This will be now minus 2 alpha beta, then is equal to what? Alpha plus beta squared, like that. So we have seen that the sum of alpha plus beta is equal to this. All right, so now just substitute. All right, so you're saying now alpha times beta squared, they should give us what? On bracket alpha plus beta, all right, squared, then minus 2 alpha beta, like that. So what we do is we say so that's, you just have to know how to derive this, guys. It's very simple. So for, you can master for x squared, and for cube you also check the video in the description. We'll post the video, so you'll be able to find for deriving these ones as well. So what we do is you bring now to say you have the value of a plus b, you have the value of a times b. So I'll put inside the bracket there, the value of ab is what? The sum is negative 2. So I'll say negative 2, all right, squared minus 2 open bracket. The product of these guys is what? Negative 5, like that. So this is 4, all right, this is now plus 10. Then that will give me what? That will give me 14. All right, so that's the sum of these two guys. We are almost there, don't get tired. Okay, so now let me just, I'm sure I have the space there. So I'm done with everything. Like, I substitute into this form. All right, this is the form I should substitute. All right, so we are saying you write it in the form a alpha squared minus open bracket. All right, so the product of these two guys, all right, I mean the sum open bracket, they should be attached with x, then plus the product of these two guys, then is equals to 0. So let's just substitute and run. All right, so you write like that. The sum we found what, 14, right? So x there, then plus the product we found what was the product? No, we haven't found the product. All right, so this is where we come in and find the product, since for beta and what, for beta and the alpha. So the product will be, see, we have this product, this is times beta is equals to -5, right? So meaning that we square them, it's more like we just put them like that. So alpha beta open bracket squared, which is just -5 what squared, like that. You see, we just square because this square distribute inside, and it's still the same case here. So it's what, 5 squared -5 squared, like that, then it's equals to 0. All right, so say x squared, this will be minus 14x. All right, so that will be minus 14x, then that will be what, positive 25, like that. Okay, it's equals to 0. Okay, then from there, I'm sure you can just leave the equation. You are done. So this is the answer that you needed. So master on how to derive these two guys when you have to find the sum of this, because they repeat questions. It can be the cube or the half, the 1 over something. Then check other videos, you'll find those ones. All right, let's go to the next question. So question 2 says rationalize the following. I mean, rationalize the denominator. Express your answer in the form of what, a over b, like that. Okay, so we are going to express this one. So what you do for such a case to rationalize the denominator, or whether the numerator, in short, they are telling you to say find the conjugate of what, denominator. And how we find the conjugate is as follow. So we say root x plus root y. All right, so we say root x minus root y, like that. So they are saying the denominator, so we'll multiply the denominator by its conjugate. So the conjugate of denominator, you say x. All right, we say x, now it is z plus, because here it's what, negative. That's a conjugate is the opposite. So now you write y there. All right, then you write the same thing over. Okay, so I put this in the bracket as well because it's more like multiplying. So I'll put the same thing there. All right, plus, you see, there's nothing you have changed. You just want to actually confuse minus, or we don't want to have the roots down, because we want to have at least those roots to be on top. That's the reason why when you say conjugate, find the conjugate of, let's say, denominator, we want to cancel something in the denominator. When you say in the numerator, we want to cancel something in the numerator. That's the goal of rationalizing. So what we do is this down there, so you multiply this times that, so x times x on top there, that will be what, it will cancel. It's more like you have what, x squared, which is x squared is what, root x squared is what, x. So that will cancel. So we'll say x times x there, it will give us what, just x. You see, the x will cancel because you have x squared in the root, which is just x. Then again, x times the y, that will be, now they are in the same root, so we'll say x y, like that. They are in the same root. All right, the root is not different. So then it's a square root. So then we'll multiply again the same y, x again is to give us what, x y. Then y times y, that will give us what, y. All right, over. So we can see it's a difference of 2 square. It's more like we have a minus b, all right, times a plus b. All right, which is just a squared minus b squared, like that. So that's what we'll do. So we'll say x squared minus root y squared down there. All right, we group the right terms on top. So of x plus y plus 2 root x y, like that, then over. the down there the root will cancel, so have x. All right, is that okay? We just have x because it's squared, so the root cancels then, you know. Yes, so let's say we have x root there, then this is same as what, x to the power 1 over half, but we have what, 2 there again as a power, so this will go, then we just remain with x. That's the reason. So here will remain just with y. Okay, so we are done here. The only thing that we can do is actually to divide throughout both